Hi everyone, in this video we're going to go through 9i, derivatives of circular functions. So the rules are there for you in the pink section summary. It's derivative of circular functions is not that difficult. You do need to know them off by heart, obviously, but and your exact values as well. So that kind of adds a layer of challenge. But in saying that, you also need to, use the derivative of circular functions in the chain rule, the product rule, and the quotient rule. So even though it looks quite simple, you do have to apply it, I guess, to more challenging questions. So the questions I've chosen, and none of these notes are in your bound book, so you'll need to add them. We've got question 2. So instead of just finding the derivative, we're going one step further and substituting in the x value. So we get a gradient at a point, or the gradient of the tangent at a point, which is the same thing, and then the y coordinate. Looking at questions 5 and 6, so we're going to be using the chain rule. Okay, so we're not using the product rule or the quotient rule with these questions yet, just because of the order that they were done in your textbook. So we might come across some derivatives of circular functions again when we do product rule and quotient rule. All right, so let's get started. So question A, get my pink pen. We've got y equals sine 2x. And we want to find the gradient of the tangent at x equals pi on 8. So we'll leave that for now. So we've got to find the derivative function. So remember, the derivative is the same as your gradient, and we're finding the gradient at x equals pi on 8. So we're finding dy dx. So if we just have a look at our section summary, there's our function. So f of theta. In this one we've got x. So theta is just another variable, just like x. So your derivative is going to be k cos k theta, or in this case, x. We're not using theta, we're using x. So your derivative of sine 2x becomes 2 cos 2x. All right, so if you can just realize that the value of k in sine 2x is 2. All right, so we take that 2 at the front of the cos, and then inside the brackets just stays 2x. All right, so we want to sub in x equals pi on 8. So when x equals pi on 8, dy dx is equal to 2 cos 2 pi on 8, which is the same as 2 cos, oh God, I can't spell. Just change that, cos pi on 4. Now, hopefully you remember your exact values. Pi on 4 is probably one of the ones I do remember. So 2 pi on 2, so 2 times, root 2 on 2. Sorry, what am I doing? Root 2 on 2. And then they cancel out, so we're just left with the square root of 2. All right, so if you're still learning your exact values, and that's okay, because you do have until your exams, but it's probably a good idea to really make an effort to learn them, because they won't be given to you on your exam. All right, so that's the gradient at x equals pi on 8. So the y coordinate, so we're going to just now substitute into y equals. So y equals sine 2 times pi on 8. So we're going to get y equals sine pi on 4, which is also equal to root 2 on 2. Now, do remember that this can also be written as 1 on root 2. The only difference is we have rationalized the denominator. So I tend to use root 2 on 2, but please remember it is the same as 1 on root 2. All right, I'm going to skip to question C. All right, so this time we've got y equals 1 plus sine 3x. Okay, so we're going to find the derivative to get the gradient. All right, so the derivative of 1 is just 0, and the derivative of sine 3x is 3 cos 3x. And we're going to let x equal pi on 6, like it says in the question here. So we get so dy dx at x equals pi on 6 is 3 cos 3 pi on 6, which is pi on 2. And this is where you need to know your exact values. All right, and that's just going to be 3 times 0, so that's 0. And then we're going to find the y coordinate. So y equals 1 plus sine. All right, when I substitute in pi on 6, I'm going to get pi on 2 again. And that y of sine pi on 2 is 1. So 1 plus 1 equals 2. All right, moving on, we might do one more from here. Oh, actually, I might do two. So I'll do a cos and I'll do a tan. So I'll do d. So cos squared 2x. All right, so because we've got this 2 here, we're going to have to use the chain rule. Now, the reason we're using the chain rule is because your cos function is actually squared. So if I had cos 2x times cos 2x, that is actually cos squared 2x. All right, so if you see the square there or any other power, we're going to be using the chain rule. All right, so using the chain rule, let's let u equal u squared. Sorry, oh, what am I doing? Let y equal u squared. So u is equal to, oh gosh, cos 2x. I probably should have written that around the other way. So dy du equals 2u and du dx. All right, so the derivative of cos 2x, if we just go up here, you can see we've got cos k theta. So the derivative is negative k sine k theta. So this one here, the derivative is negative 2 sine 2x. And I'm just going to substitute u back in. So 2 cos 2x. All right, so dy dx. So with the chain rule, we're just going to multiply dy du by du dx. Usually I would do them around the other way, but anyway. All right, so 2 times negative 2 is negative 4. And then we've got cos 2x sine 2x. And it doesn't matter whether you put cos or sine first because you are multiplying. All right, so we're going to let x equal pi on 4. So let's substitute that in. So we're going to get dy dx equals negative 4 cos, that's going to be pi on 2. And then sine pi on 2. And because cos pi on 2 is 0, we're going to just end up with 0. All right, and then getting the y coordinate, so substitute in pi on 4 into y. I just need to make that a little bit smaller. So we've got cos squared. Now we're going to have pi on 2. So we know that cos pi on 2 is 0, so we're going to have 0 again. All right, let's do a tan. So we'll do question F, tan 2x. All right, so finding the derivative, so dy dx. Now with tan, it's slightly different because you got sine and cos complementing each other, but tan, we get k sec squared, k theta. So if you're interested in, I don't know whether I explained this earlier, if you're interested in the theory behind the derivative, just your textbook does explain it. All right, so you can go through it, but I'm not going to go through it here because it'll be a very long video. All right, so k sec squared, k theta. All right, sorry, I just had to edit some things out because I wrote the wrong thing. 2 sec squared 2x is your derivative. Now, sec squared or sec is the same as 1 over cos. So I might just write that over. Actually, I might show you in the textbook. It might be easier. Okay, so here it goes through the proof of sec squared. Sorry, not sec squared. Of tan theta. So you can see just in the first green box, we've got sec theta equals 1 over cos theta. And if we keep going down, you can see the proof of the derivative of tan. But just before we look at example 31, you've got 1 over cos squared theta is equal to sec squared theta. So when you're doing your exact values, it's probably a good idea to see that as cos squared theta or cos squared 2x, because when we're substituting it in, you're more familiar with the exact values of sine, cos and tan as opposed to sec or the secant. Okay, all right, let x equal, what was it? Pi on 8. So when x equals pi on 8, we get dy dx is equal to 2 cos squared 2 pi on 8, so pi on 4. So we're going to have 2 cos pi on 4 is root 2 on 2. And then we're going to square that. All right, so when we square that, I'm going to keep that on the numerator. So root 2 squared is 2 and 2 squared is 4. So basically we've got 2 divided by 2 on 4, which is the same as 2 times 4 on 2. So they cancel out and I'm going to squeeze the answer in there, which is 4. All right, so the important thing here is to remember the derivative of tan is sec squared theta, or yeah, depending on what your variable is, x or theta, but that is the same as 1 over cos squared. All right, and then when you're substituting it in, it's obviously easier to do your exact values of cos than what it is for sec. All right, I'm going to, in this little spot here, substitute in y. So when x equals pi on 8, y is equal to tan pi on 4, and that's just 1. So not as much working out there as we did for the gradient. All right, moving on now for question 5 and 6, we're going to be using the chain rule. So I might just do one from question 5 and one from question 6. So I might do 5b just because we've got a tan in there and it's probably a little bit harder. So if y equals negative log base e tan x, we've got to find dy dx, and I don't know why I wrote if. Okay, so we're going to let u equal tan x. So that means du dx is equal to sec squared x. And then y is equal to negative log EU. So dy du is equal to negative 1 on u. So doing the derivatives of logs. All right, so bringing it together to get dy dx. So we've got sec squared x times negative 1 on u, where u is tan x. And we're going to have negative sec squared x on tan x. Now you'll notice that your textbook might be putting these answers in a different format because they're using the trig identities, and you don't really need to know the trig identities, but I'm going to do it here just for those who are interested, or maybe you've learnt them in Specialist. So I'm just going to go on from here. Okay, so remember sec squared x is 1 over cos squared x. And if I just do on the side here, tan x is equal to sine x on cos x. All right, so that's the relationship between sine, cos, and tan. So what I can write here, instead of -1 on tan x, that is the same as negative cos x on sine x. So I've just done the reciprocal because we've got 1 on tan x. So instead of being sine on cos, it becomes cos on sine. Now, this cos cancels out with one of these coses, and then we're left with -1 on the top, and then on the bottom, cos x sine x. All right, moving on to question 6. So I'm just trying to see which one is probably the harder of the two. Doesn't really matter. Let's just do B. All right, probably should have read it first. Y equals E cos 2x. Okay, so your derivative, we're going to use the chain rule. So let U equal cos 2x. So du dx. So the derivative of cos is negative sine 2x. And then we've got y equals e to the power of u, so dy du. So that's just going to become eu. Now someone's walking down my driveway. I don't know whether they're going to see me, so my dog starts barking. She's barking at this person walking down my driveway. All right, so we've got negative sine 2 sine 2x times e to the power of u. All right, it's very hard when you get distracted. All right, e to the power of u, what is that, cos 2x? All right, sorry, I had to pause because I was getting really distracted. Yeah, so I think the important thing for you to understand is probably, as you can see in 5B, how I wrote the answer differently. So you're not expected to know these trig identities. Okay, so leaving your answer as negative sec squared x over tan x is fine. But then if you went ahead and wrote -1 over cos x sine x, that's also fine. All right, girls, bye.